Newton's forward difference formula and Newton's backward difference formula. So first I define what is finite difference. Finite difference. Let y equal to f of x be any function, let y equal to f of x be any function given the values f of x naught, f of x1, etc. up to f of xn for regularly spaced values x naught, x1, etc. up to x. That means this x naught, x1, x2, etc. are regularly spaced. That is x naught. The distance between x naught and x1 are same. X1 and x2 are same, etc. So that is regularly spaced means x naught is equal to x naught. Now x1 is equal to x naught plus some uh, distance h, and x2 is equal to x naught plus h, that is 2h. So similarly etc. up to xn is equal to x naught plus nh. That means each points are equally spaced. Okay. So that is important. Each points are equally spaced in this regularly spaced in this finite difference format. Okay. Now I define what is first finite difference. First forward difference. The first forward difference. The first forward difference of f of x at point xj is defined as is defined as is defined as delta fj. We will denote delta fj is equal to fj plus 1 minus fj. That means fjth value. Fj means simply f of xj. So therefore what is delta f naught? F naught is f of x naught x1 minus f of x naught. So delta f naught is f of x1 minus f of x naught. Similarly, delta f1 is f of x2 minus f of x1, and so on. Delta fn is f of xn plus 1 minus f of x. So next I will define what is second forward difference. Second forward difference. So it is denoted by delta square fj is equal to delta fj. Delta fj j plus 1 minus delta fj. That is delta square f naught is simply delta f of x1 minus delta f of x naught. Delta square f1 is delta f of x2 minus delta f of x1. So on. So in general, kth forward difference is we denoted by delta power k fj is equal to delta power k minus 1 fj plus 1 minus delta power k minus 1 fj. Okay. So that is, you want to get delta power k f naught. This is delta power k minus f of x1 minus delta power k minus 1 f of x0. So in general, this is a fourth difference, forward difference. Now we can easily denote it in a table. Okay. So now what we will do is, so this is a kth forward difference. Similarly, we can define backward difference. Similarly, what is first backward difference? There is no change. Actually, there is no change because only there is a change in the notation. Here we are using delta. In backward difference, we are using nebula. That means reverse delta. Nebula fj is equal to nebula, fj plus 1 minus fj. That is first backward difference, nebula f1 f naught is equal to f1 minus f naught. That is equal to f of x1 minus f of x0. Now what is second backward difference? This is same. There is no difference. Only there is a difference in the notation. That is delta square fj is equal to delta fj plus 1 minus delta fj. And kth backward difference is nebula power k fj is equal to nebula power k minus 1 fj plus 1 minus nebula power k minus 1 fj. So there is no difference, only the difference in the notation. Okay. So these are finite difference, backward difference and forward difference. Now we will move to Newton's formula. Newton's forward difference interpolation formula. So Newton's forward interpolation formula. So let y equal to f of x be a function which takes the values y0, y1, etc. up to yn. That means y0 is simply means f of x0. Okay. And y1 is means f of x1. Corresponding n plus 1 values x0, x1, etc. xn of independent variable x. Let the values of x be regularly spaced. This is very important. In order to use forward difference formula, Newton's forward difference formula, these values, x values must be regularly spaced. That is, x1 minus x0 is equal to h. That is, x1 is equal to x0 plus h. x2 minus x1 is equal to h, and so on. And so on. Okay. Now, now we have to find out the interpolation polynomial, that is in the formula. So Newton's forward difference interpolation formula is f of x is equal to f of x naught. Here importance is f of x naught plus r into delta f naught. So I will tell you what is r. Plus r into r minus 1 divided by 2 factorial into delta square f naught plus r into r minus 1 into r minus 2 divided by 3 factorial into delta cube f naught, etc. up to r into r minus 1 into etc. r minus n plus 1 divided by n factorial into delta power n f. Okay. So this is called Newton's forward interpolation formula. Now we will okay. Now what is x r? X is equal to x naught plus rh. So we want to find out for some x values, value of f of x at some x, and x is equal to x naught plus rh, where r is equal to x minus x naught by h. So r is equal to x minus x naught by h. So this is Newton's forward interpolation formula. So remember one thing, here we are using only f naught or f of x naught, delta f naught, delta square f naught, delta cube f naught, etc. Now next is Newton's backward interpolation formula. So this is same as Newton's forward interpolation formula. There is some difference. So Newton's backward interpolation formula. Let f of x be a function which takes the values y0, y1, etc. yn corresponding to the values to the n plus 1 values x0, x1, etc. xn of independent variable x. Let the values of x be regularly spaced. This is important, regularly spaced. That means difference between x1 and x0 must be equal to e h, x2 minus x1 is equal to h, etc. That means difference between x0, x1. This distance is always h, and this distance is always h, and so on. Where x is xn plus. Okay, now Newton's backward difference formula is f of x equal to, here we are taking xnth value, last value, back value, f of xn plus r into nebula fn. So here we are using only last values. R into, instead of r minus 1, this is r plus 1 by 2 factorial nebula square fn, r into r plus 1 into r plus 2 divided by 3 factorial into nebula cube fn, etc. r into r plus 1 into etc. up to r plus n minus 1 divided by n factorial nebula raised to fn, where x is equal to xn plus rh and r is equal to x minus xn by h. So now in the question they will not give whether you have to use Newton's forward difference formula or backward difference formula. So we have to identify from the question. So we will do a problem. Then we will. For the following data, calculate the value of y. Y means f of x equal to f of x when x equal to 9. Y when x equal to 9. Here in this question, this is stated July 2017 question. In this question, it's not given that you have to use whether forward Newton's formula or or Newton's forward difference formula or not. So now how to identify this? Let's so here we have to find the value in between these value 8, 10, 12, 14, 16, 18. Now there are many methods. Newton's divided difference is there, but here this is equally spaced, right? So from the question itself, the x values are equally spaced. Therefore, we have to use uh, forward or forward or backward difference formula. Now we have to check where the value x is equal to 9. So x is equal to 9 means it's nearer to x naught, right? X naught is 8. Here x naught is 8. So it is nearer to x naught. X naught is equal to 8. X equal to 9 is nearer to x naught is equal to 8. Therefore, we will use forward difference formula. Now, if you want to find x equal to 17, then this is nearer to xn, right? xn or last value. Then we will use backward difference formula. So we have to check where it is nearer to. If somewhere in the middle, you can use you can check the average, and if the average is greater than that value, then you can use forward. If average is less than that value, you can use backward. Okay, so now first we will draw the table, so then it will be very easy to find the difference table. There are x values and y values. There are x values and y. And okay, now x values are there. Y values. So first, this is x values, y values, y equal to f of x values. Then we will find delta y value, delta y, or this is delta f, first difference, forward difference, and second forward difference, delta square y, and next third forward difference, delta cube y. So here 1, 2, 3, 4, 5, 6. At least 5 delta raised to 4y and delta raised to 5y. Now we will write what are the x values first. X is x, 10, 12, 14, 16, 18, and f of x values. Sorry, this is 8, right? 8. 10, 19, 32.5, then 54, 89.5, 154. Now delta, we know that delta y is this minus this. So delta y1 is 19 minus 10. 19 minus 10, which is equal to 9. 19 minus 10, which is equal to 9. Next, this minus this. 32.5 minus 19. That is 13.5. Next, 54 minus 32.5. That is 21.5. Next, 89.5 minus 54. That is 35.5. And 154 minus 89.5. That is 64.5. Now next is delta square y, second forward difference. Then we will subtract it from here. 13.5 minus 9, that is 4.5. 21.5 minus 13.5, 8. Next 35.5, 21.5 minus, so that is 14. 64.5 minus 35.5, 29. Now third difference, that means 8 minus 4.5, 3.5. 14 minus 8, 6. 29 minus 14, 50. Now fourth difference, this is 6 minus 3.5, 2.5. Now 15 minus 6, 9. Now last forward difference is 9 minus 2.5, that is 6.5. So this is actually so we are using forward difference formula. So this is f naught, this is delta f naught, this is delta square y, f naught, delta cube f naught. So now we will use the formula. Okay, so what is the formula for finding? So here x equal to 9, we have to find out y of 9. X equal to 9 is very near to the starting value. X naught is equal to 8. So we compute y of 9 using Newton's forward difference formula. And we know that first we have to find out r. R is equal to x minus x naught divided by h. And we have x is 9, x naught is 8. 9 minus 8 divided by h is the difference, right? Equally spaced. So h is equal to 2. Is equal to 0. 1 by 2, 0.5. Now we will write Newton's forward interpolation formula. Forward interpolation formula. So that is equal to f of x is equal to f of x naught plus r into delta f naught plus r into r minus 1 by 2 factorial delta square f naught plus r into r minus 1 by into r minus 2 divided by 3 factorial into delta cube f naught plus etc. So now we will calculate this. I'm writing it here so that so I'm writing here, so that is equal to first f of f naught or y naught is equal to 10 plus r 0.5 into this 9 plus r into 0.5 into 0.5 minus 1 divided by 2 factorial into 4.5 delta f naught f plus 0.5 into 0.5 minus 1 into 0.5 minus 2 divided by 3 factorial into this delta cube y naught into 3.5 plus next 0.5 into 0.5 minus 1 into 0.5 minus 2 into 0.5 minus 3 divided by 4 factorial into this 2.5. Similarly, plus next last 0.5 into 0.5 minus 1 into etc. up to 0.5 minus 4 divided by 5 factorial into 6.5. So if you calculate this, you will get the answer as 14.25. Therefore, thus the value of y of 9 is equal to 14.25, approximately 14. Now I will the time is, so I will define show you Newton's a problem involving Newton's backward difference form. Okay, so in this problem, so listen here, in this problem calculate the value of 7.5 from the table. So 7.5 is here nearer to xn, right? Back. So we will use backward difference formula. So now we will find the table. Okay. So you write xj, fj, delta fj, or if it is backward, delta nebula square fj, nebula cube fj, etc. Now if you calculate this, then after that you have to find out r. R is x minus xn divided by n. Here x minus xn. So x is 7.5 minus 8 by 1, 0 minus 0.5. Xn is 512. So we will calculate the value, and here in the backward formula we will use this delta fn, fn, delta fn, sorry, fn, delta fn, delta square fn, delta cube fn, delta raised to 4 fn, delta raised to 5 fn, and we will use Newton's formula, and just to substitute, you will get the answer. So I hope it's clear, and I will